Hi guys, good morning. Today I'm going to introduce to you the Hioki CM3281 3286-01 power clamp meter AC clamp power meter. In particular, I'm going to show you how to use the energy comparison function of this remarkable instrument. If we have used a clamp style multimeter before, the operation of this one is very similar. The jaws, we use this to clamp the conductor whose current you're going to measure, and of course the voltage probe, you connect this to the any of the voltage monitoring points you wish to monitor. Measuring voltage and current is fairly straightforward. You just put the dial on the corresponding function. This is the power and energy, three-phase balanced or unbalanced power measurement, including phase detection. This instrument does not measure resistance like an ohmmeter. It does not measure DC voltage or DC current, but what it lacks in the DC area, it more than makes up for the lack of those functions in the AC area. Of all the functions of this clamp meter, the one that really stumped me before was the watt-hour setting, especially the energy comparison function. This is because in order to use this energy comparison function, I had to understand a little about meter constants. In this particular instance, the instrument, after putting it on the energy setting, it's waiting for me to start the measurement. But as you can see, at the bottom, there is the energy, the meter constant saying 500 cycles per kilowatt hour or per 1 kilowatt hour. This is the function that confused me before because I did not understand it at first. If we scroll to the menu, we can see that there are several choices of meter constants. But the one we're most interested in is the 500 cycles per kilowatt hour, because this is the meter constant that corresponds to the meter that we're going to use later on, whose meter constant is 500 impressions per kilowatt hour. So how does this energy comparison function relate to meter constants? Well, the way I understand it, meter constant is a fixed value of energy for any given measurement method for a multimeter. For example, for this meter that I'm going to use later on, the meter constant is 500 impressions per kilowatt hour. What that means is that the LED light of that meter will pulse 500 times in 1 kilowatt hour. In other words, in two consecutive pulses, or between two consecutive pulses, that meter will record an exact amount of 2 watt-hour. That is 1000 watt-hour divided by 500 impressions. So 2 watt-hour per impression. Now suppose I have already set up this instrument and I'm ready now to begin synchronizing the measurement of this meter with that other meter. The moment the light of that meter pulses or pulsed or flashed, I'm going to press the hold button, which means to start the measurement. And immediately we will see the 2 watt-hour expected measurement value when we stop the measurement. This other one, the value here, this is the time elapsed, and rotating lines means that the instrument is gathering data. So for instance, to stop the measurement, we wait for the next pulse of that meter and press again the hold function. So In the screen now, we can see that the measured value here is 0 because we have not yet actually started using the instrument to measure the energy. But that's what the value here represents. This the energy measured by this instrument. This is the expected energy within that pair of pulses, 2 watt-hour, and this value is the difference between the measured and the expected. And this upper value here, the percentage value, this is the percentage of the ratio between the measured and expected watt-hour. So the significance of this measurement is that these two values at the bottom should be the same, or at least very close to each other, if the meter and this instrument are measuring correctly. So since we assume that this meter is measuring correctly and accurate, it's like we're checking whether that meter is also as accurate as this one. And the other thing that this energy comparison function can be applied to is that according to the Hioki website, this clamp meter can be used to detect electricity theft or energy theft. That is why the energy comparison function is significant, since if these two values are very much different, the measured value, for example, is much higher than the expected value, then that meter is measuring much less than it should measure, or there is some energy that this clamp meter is measuring that does not pass this other meter. And I have actually wired my board here to simulate that one. First things first, we are going to just demonstrate now how to use the energy comparison function. We'll reserve the energy theft detection function on a later demonstration. This is the meter whose reading or whose pulses we will synchronize with the Hioki clamp meter. As you can see, the meter constant here says 500 IMP per kilowatt hour. That means 500 impressions per 1 kilowatt hour. That is just another way of saying that the pulse here will light up every 2 watt-hour of energy passing through this meter. So we will start our measurement on the clamp meter when we see the pulse light up, and then again we will stop the measurement when this pulse light lights up again. So that's how we synchronize the energy measurement between the two meters. For this demonstration, let's connect a 400 watt oven to our test board here, and this one is connected to the energy meter. For now, let's start the oven and just observe first what will happen to the energy meter. As you can see, the LED pulse lit up once, and we will synchronize the start of the Hioki clamp meter at that pulse and stop at the next pulse. Right now I'm going to set up the clamp meter for the measurement test. So I'm going to clamp the jaws of this clamp meter to the main line, which will measure, of course, the current going through the meter, the energy meter, and to the load. And then I'm going to connect the voltage probe at these two measuring points for voltage, and we can begin the measurement. I'm going to switch on the load now and watch out for the first pulse light to start the Hioki measurement. that's a start. So you can see that the lines now in the screen of the instrument is rotating, and we will wait now for the next pulse to stop the measurement. So there you go. So the reading now here is, I'm getting expected reading of 2 watt hour and a measured value of 2.04 watt hour. There is a difference of 0.04 watt hour, that is close enough, and the ratio is 101%. Now what I would like to point out is that of course there is no communication between the clamp meter and the energy meter that we are basing our comparison with. So it's up to us, the operator, to detect the light and consequently press the start button as perfectly timed as we can. But of course that is not always possible, so there would be some discrepancy there. We are going to test one more time. Let's start. Stop. Let's see the values. So here our timing is much better. We measured 2 watt hour against an expected value of also 2 watt hour. So the difference is 0, of course, and the ratio between expected and measured values is exactly 100%. So that's it. It means that the energy meter is functioning properly, and for this measurement, I'd like to point out also that it doesn't matter if you begin measuring at the first pulse and stop measuring the second pulse, for as long as you begin and stop measurement on two consecutive pulses of the energy meter, that would be fine. And also one of the unique features of the meter constant is that if your load is large, then it would take a much shorter time between pulses, and if your load is smaller, then the pulses would be much farther apart. But the thing is that whether the load is large or small, it is always 2 watt hour of energy that is recorded in the energy meter between pulses. Of course, that's for the energy meter with a meter constant of 500 impressions per kilowatt hour, like our meter here. The zero point 0.3 digit there is not zero point 0.3 watt hour, but 0.3 kilowatt hour. So that's a very large value compared to the 2 watt hour that we're measuring. That is why using the meter constant of 500 impressions per kilowatt hour would result in a much faster and also accurate value of results for as long as we time our start and stop of measurement as perfectly as we can. So that's it, guys. I hope this short video had been somewhat instructional to you. If you own this meter and would like to find out how the energy comparison function works, and that's one of the ways how to demonstrate or how to set up the instrument for this kind of measurement function. This is the electrical demonstration board of my own design and making. Most of the components of this demonstration board, from the acrylic, the lumber that I've used, outlets, switches, the Phelps Dodge wires, terminal block, including the miniature circuit breakers on top, they were sourced from local online suppliers. The blue meters here and the other meter on top with the red numeric display were sourced from also from online sellers, but from overseas suppliers. The blue residual current breaker here, this is the main disconnect of the whole board. If I turn that off, the whole board is powered off. The breaker next to it, this is the protection of the board, which is just 10 amperes. I could turn that off too, and it will power off outlets, the whole outlet bank here. The breaker next to it, this is the disconnect of the energy meter, which is connected to submeter 1 and outlets 1 and 2. And the breaker next to it, this is the disconnect of the outlet 3 and submeter 2. Now submeter 2 and submeter 1 are independent of each other, so I can turn on submeter 1 or outlets 1 and 2, and outlet 3 will remain off. Likewise, I can turn on outlet 3 and turn on outlet 3 and submeter 2, and turn off submeter 1, outlets 1 and 2, and submeter 2 will remain on. When I put the instrument, the clamp meter in this location here, it will measure all the current going, all the power or energy going through all the outlets here. If I'm just measuring one quantity at any given time, like current only, and this is the conductor whose current I'm going to measure, the direction of the arrow at the clamp wouldn't really matter. I could point it toward the load, as indicated by that arrow on the conductor, and the instrument will measure current correctly. Or I can reverse the direction of the arrow in the clamp, and it will still also correctly measure current. Likewise, if I'm measuring voltage only, in this case I'm going to switch the function to voltage, and I'm going to measure here. It wouldn't matter where I point the red probe, whether on line A or line B, and it will measure voltage properly. I can swap them, put the red probe on line B and the black probe on line A, and the voltage is still correctly measured. However, when we're measuring power or energy, for example for power, which is a measurement or an integration of 3 different values at the same time, voltage, current, and power factor, the instrument's internal microprocessor requires a certain fixed reference point. In other words, the conductor being clamped, this one, and the red probe must be the same line. So if we put this one now, let's say we put this one to the power measurement, and I put the clamp, the jaws of the clamp, I align the arrow towards the direction of the load, and I get a warning, a red flashing warning. That means the orientation is wrong. That means somewhere in my connection point something is wrong, and the requirement of this instrument is that the line being clamped, or the conductor being clamped, must be the same line as the red probe. And since the line being clamped is line A, in this case line A, therefore the red probe must also be connected to the line A for voltage monitoring, which in this case is the lower part of the outlet, and that will give us a correct power measurement. The same goes for energy. measurement, which is an integration of 4 different values at the same time: voltage, current, power factor, and now time. So it also requires the correct orientation of the current clamp and the voltage probe. So my oven is now running at 400 watts nominal. Let's look at the reading of the small meter. So it reads 400 watts, 1.86 amperes, 0.92 power factor, 60 hertz. Let's look now at the Hioki's reading. It's 400 watts, 0.916 power factor, 1.86 amperes, nearly identical to the small meter.